Hi, my name is Ira Plinsky, and today we're going to solve the inequality 4 minus 3 times the absolute value of 2x minus 1 is less than negative 8, and then graph it on a number line. Okay? The first thing we need to do is isolate the absolute value term by itself. We need to get rid of all numbers in front of it that's multiplying by it or adding and subtracting. And remember, we use the opposite of PEMDAS when we are doing an equation and solving for variables. All right, so we would take the negative 8 and subtract the 4 from the left side. So 4 minus 4 is just 0, and negative 8 minus 4 is negative 12. So we have negative 3 times the absolute value of 2x minus 1 is less than or equal to negative 12. Then we want to divide by that negative 3 on both sides. So negative 3 divided by 3 is just 1. Negative 12 divided by negative 3 is 4. But since we divided by a negative number, the inequality sign goes from a less than sign to a greater than sign. Anytime, or equal to sign. Less than or equal to greater than or equal to. Anytime you divide by a negative, you switch the sign from greater than to less than, or less than to greater than. Okay, and we have the absolute value of 2x minus 1 is now greater than 4. All right, so now that we have the absolute value isolated on one side and just a constant term on the other side, we can draw our number line right away. Since it's greater than or equal to, we place a solid dot at each of the endpoints. If it was just greater than, we would place an open circle. But since it's greater than or equal to, we place a solid circle. And since it's greater than instead of less than, we take arrows and we move them outside from each of those initial dots. If it was less than or equal to, we put a bar in between the two showing that. But since it's greater than, we move it outside. And since it's greater than or equal to, we have a solid dot and arrows that go outwards. All right? Essentially, we want to build a wall around things that are inside so that all the stuff that we put in goes away from it, because we want to be outside of our perimeter. All right. Now, when solving an absolute value equation, or in this case, inequality, we set up two separate inequalities. One is whatever's inside 2x minus 1 is greater than what we had here 4, or we take the opposite, which is 2x minus 1 is less than or equal to negative 4. We need to have both of those points in our inequality, because whenever you're doing an absolute value, it could be either the positive version or the negative version. Okay? The positive version would be greater than, and now since it's the negative version, we're dividing by a negative 1. We switch the sign to be less than. All right, so we have 2x minus 1 is greater than or equal to 4. We would add the 1 to both sides. We get 2x is greater than or equal to 5, because 4 plus 1 is 5. Divide by the 2 that's in front of the x, the coefficient of x. Divide 5 by the coefficient of x. X is greater than or equal to 5 over 2. We could write it as a fraction, 5 over 2, or we could write it as a decimal, 2.5. Whichever you think is easier for you. Now we're going to do the negative side. 2x minus 1 is less than or equal to negative 4. Again, as we stated, because we changed it from a positive to a negative, we flipped the sign to be less than because it was originally greater than. Now we add the 1, Negative 4 plus 1 is negative 3. 2x divided by 2, negative 3 divided by 2. That will isolate the x. So x is less than negative 3 over 2. Now we take each of those numbers and place them onto the number line that we drew originally, with the smaller of the two being the term to the left and the larger being the term to the right. And so we place the negative 3 over 2 by the left-hand solid dot, with the arrow pointing to the left, and the positive 5 over 2 on the right-hand solid dot with the arrow going to the right. And remember, this is to place objects outside of a given perimeter. Okay? Thanks for watching.